So it looks like we should be live. There are 18, 19 people watching live. So hello to you all if you're watching live. Unfortunately, we couldn't be at Productronica this year. The restrictions to travel were lifted, but it just didn't seem right making travel, considering it's a pandemic that is bolstered by people's movement, so it just didn't seem right to make the travel. But hopefully the technology is working today and we can do this live stream. Some of you watching might not find this first bit of the information new, so hang on to the end of the stream and we'll do a quick Q&A for anyone who's wanting to ask me any questions. So for a quick introduction, my name's David and I'm the product manager of the SMEMA Hermes Adaptor at British Systems, which we trade under for ir.uk. So 2017, and a consortium of equipment suppliers wanted to create a new data standard to essentially mimic SMEMA. SMEMA was a bespoke, discrete connection between industrial equipment, the manufacturing equipment of in the electronic assembly space. It's quite a simple messaging system. It relied on two machines saying they're ready, one with a board and one just generally ready, and if both of them were ready, then a board would move, a printed circuit board would move between equipment. Having said that, we now live in the world of Ethernet networks, so it seems sensible to try and get rid of that kind of old connection. Secondly, it didn't come with any metadata, it didn't come with any data that said anything about the product that was moving between the machinery, and so additional barcode scanners would have to be used to constantly look up what was actually on the board. So Hermes came along again 2017, so we're now 4 years in now. They haven't quite finalized it. They have a meeting a couple of times a year. I'm hoping that in 2022 we can actually finalize the Hermes standard. We started the product 2 years ago, initially just to understand if we can extract data from Hermes, but there seemed to be a need for legacy equipment that may be out of service or maybe just fairly dumb, and so there was no software upgrade path. There was a need for an adapter. So this is our adapter, fairly small, lightweight, low cost. Here it's mounted on a DIMM rail, and essentially what it does is translates the Hermes messages into SMEMA signals and then back again. So the actual equipment that it's attached to is attached to both upline and download SMEMA connections. Believes it's still talking to the machines upline and downline, but actually it's talking to the Hermes messages of the upline and downline. So it does the translation. It's on the whole, it's a headless device, meaning it has no user interface. It shouldn't need a user interface in normal running. It should be just a switch on and it starts working situation. However, it does have a browser-based user interface. All the software is based on the MultiPlug edge computing platform, and that gives you software flexibility to add more extensions to MultiPlug. MultiPlug is based upon extensions. Hermes is one of the extensions of it. Network sockets is another extension. The I/O is another extension, and you kind of map all the messages internally within MultiPlug together. So there's basically a trigger system, an event system that occurs, and you can create new extensions if you want to create bespoke connections to new devices, or you can download new extensions and map them all together and create a solution. So it's very flexible. It's very in line with Industry 4.0 of high level of flexibility, and this device could have been a more of a firmware fixed device really, but again, with that Industry 4.0 mentality, high level of flexibility, this is kind of targeted at the IT professional. So obviously it's a network device, so that's very IT, but it's very much pushing the solution back to the customer, allowing them to configure solutions as they see fit. Of course, out the box it will come with a default configuration, which is very simple, mapping Hermes messages to SMEMA signals, but you can make it more complex as you see fit. You can push data, you can pull data as you see fit, and have your own solution. So the connections to SMEMA, quite simple. Connections to the adapter, and then you have the SMEMA connector on the other end. We sell these in both male and female, so this is a direct machine connection, this is a male connection, fairly short cable because of that reason. We also sell female, which is more of a extension lead scenario where you want it to go to a longer situation, so they come in different sizes, and it simply connects to the bottom of the adapter. The adapter is powered by USB-C, so that's 5 volts, 3 amps. So your first option would be direct 240 110 volt power brick on one end and USB-C on the other. If you don't feel like you're wanting to run high voltage down to your equipment for any reason, or maybe it's not very neat, you might be already using 24 volt industrial power. So there's these step down bricks you can buy. So USB-C on one end, any sort of connection on the other, you can just wire it in as you see fit, and then there's a step down transformer there. So that's for 24 volts. A more neater solution is to use power over Ethernet. So we supply these breakout boxes, so you have Ethernet cable on one side and then the USB-C on the other. So that just connects to your USB-C on the bottom, and then Ethernet on the side. Ethernet on the side, and then there's your Ethernet cable that goes to your network switch. If your switch isn't producing power over Ethernet, which is quite likely, you can buy some injectors. There's an injector, so you put your mains voltage in that way, and then you loop in, loop out of the Ethernet on the other side. So this injector can then go either up high next to a power socket, or it can even go in your the cabinet of your switch, so quite a long way away. So that will power it, and that will make it a much neater job, because all you then need is just one Ethernet cable down to the adapter. Mounting, as you see, we recommend a D-rail mount, which is that version. We also do a wall mount, just simply very fixed, 2 screws, not going to go anywhere. Also, because obviously the equipment is normally metal, you can put magnets on the back We wouldn't recommend that situation if it was up high or it's going to be hit by anything, but if it was in a cabinet or within the machine, then that's certainly an easy way to mount it. So the adapter itself, you've got the LED status of both SMEMA and Hermes on the front. You've got Ethernet, USB for barcode readings, for example, if you want to make a more complex solution. For example, double checking, making sure that the board that comes through the Hermes signal is the same as the board that's scanned, even though we're trying to remove barcode readers. I'm sure there's going to be opportunities where you just want that double check. We also have a serial port, so if you connect this to a conveyor and it needs to know board widths, it can go off and send that information out to the conveyor, and then not only do you get a signal back from SMEMA to say machine not available, you might get also machine not available via the SMEMA, or maybe you have to get a double check from the conveyor that is ready. If you've sent a new width, obviously it needs to adjust. So those are the mounting options. The power options, there's the difference. The cabling of the SMEMA, quite simple. We've tried to target it at a good, reasonable price. We'd seen this as an off-the-shelf product, so we want to make it simple for the customer to just make a quick, easy purchase. As I say, simple solutions are out the box. Anything more glamorous, there probably are extensions already available. It's a good idea to touch base with us to give you an option of a solution. Essentially, at the end of the day, it's pushing and pulling data. It's nothing more glamorous than that, or stopping before if a certain requirement isn't met. So it should be all simple stuff, really. We're shipping this from the UK at the moment. There's been lots of inquiries around the world, especially in Asia, where we've been asked if we've got any distributors. I imagine in 2022 we might have some distributors in that kind of part of the world. If you are one, if you want to be one, if you know one, please let us know. That said, we are trying to make this off-the-shelf purchase. We are trying to make it a simple purchase. So, we are selling it from smartfactorydirect.com at the moment, which is our UK distributor. But yeah, it's quite obvious when we're trying to serve around the world, and they want some level of guarantee that we'll have to go down the distributor route. But that will happen in time. At the moment, we're going to be shipping from the UK, so lead time will probably be a week or so by the time it gets to you. Price is reasonable, as I said. I won't say that what it is at the moment because it will date the video. I hope to upload this later. Should stay around that mark, I'm hoping. Supply, at the moment we are happy with the first batch. We've got a first batch which should satisfy the first chunk of inquiries we've had over the 2 years. If you're watching this at a later date, we've got the second batch, should be confirmed February 2022. Apart from that point onwards, it depends when you're watching this, doesn't it? So just check the website and that will give you a stock number of what we can fulfill. If you have bulk orders, you can contact us beforehand. I'm always open to your suggestions for improvement, and we're limiting this to 2 customers to allow you to do your own evaluations. and then we'll open you up, allow you to make more. Obviously, a typical line might have maybe 4 or 5 of these, depending on how much of your equipment can be upgraded, or you might not want that upgrade really. I mean, this is, again, Hermes is a not currently fixed messaging format standard, so you might want to just put the weight over to the adapter for now. So probably go to a Q&A for those watching live. For everyone else watching the re-record, I will probably put a demonstration of the software right about now.
A few moments later.
So that virtual product event worked out really well for us. It was all a bit last minute. We weren't sure whether we were going to go to Productronica or not. We didn't, but it's certainly something to consider for the future, and maybe creating a virtual trade show so everyone can submit videos and launch products in a dedicated website maybe. This is the future now, because after that we got a lot of inquiries from new customers, new questions, so we've been busy working on that. So this is a bit of a delayed demonstration. So first of all, I want to show you the software. So if we go to the Discovery app, we need to select this adapter. The Discovery app is just a companion app. It makes it easy to discover the adapter on your network. And this is the main operator page of the adapter. This is a headless device generally in use, but there is a user interface if you need to change settings or monitor what the adapter is doing. So you get 3 columns: upline, this station, whichever that is, attached to the equipment you're attached to, and downline. But first of all, I just want to quickly go over the MultiPlug. MultiPlug is the software that runs at the platform layer, and it's made up of the actual adapters. Solution is made up of lots of extensions of the MultiPlug, software extensions. So I just want to go over what MultiPlug is, because it's very flexible, and it can be deployed on different devices and in remote or local use cases. So you've got the main platform here and extensions that attach onto it. The contract between the extensions is pretty simple. It's pretty much events, and those events just have messages on them, so it can be really flexible of what the events and the messages are. So one extension creates an event which other extensions subscribe to. Out of the box, the MultiPlug gives you an HTTP server, which also then gives you a REST API. REST API is a very well-known API structure for the web community, the digital economy as they call it, and it's really flexible, and each extension can provide their own REST API. So again, there's a decoupling between the extensions themselves. When you have the web browser, web server, you then have a web browser user interface, which we've coloured in black here because it's not really on the web, it's on the edge. What they used to call on-premise software, essentially. And the beauty of this is you can take small steps. You can start to move towards web-based technologies, but not actually go on the web. And I think there was a big stalling period where we knew we had to go to the web to move data around the place or process data in a cloud environment, but factories were very nervous about doing that. So this is a kind of stepping stone approach. And when it's in the web browser, it means it can be accessed anywhere on your internal network, which means you automatically get remote control. out the box, where traditionally, and I'm afraid I still see this in the industry, people are creating desktop applications, and the problem with a desktop application is it's not flexible. You can only get certain types of people developing for those desktop applications, and you have to install that desktop application on any device you want to connect to. So there's always a permission level there, where most computers today will have a browser, and then you can easily access whatever device you're trying to talk to. It also aligns to Industry 4.0, and I think Industry 4.0 is being very misunderstood, because essentially what Industry 4.0 was a flag to say that actually there are a big development community out there that are ultimately working on the cloud and the web and the internet, and we need to use these developers, and then we need to allow them to extend our platforms. Using web-based technology is the answer. It's the language link between the factory and manufacturing and what they call the digital economy, which is what you could say is the .com, web, cloud, internet. And so this is once again a people stepping stone to work towards working with people outside your business or your factory. Another thing that MultiPlug gives you is a WebSocket. It's just like a normal a network socket essentially, which means you can create live updates of your user interface. And it also gives you SSDP discovery, which we've already seen using the Discovery app. This is something I would encourage everyone to implement in their own solutions. Essentially, an application can go out and say, are there any multiplugs on the network? And all the multiplugs reply back saying, I'm over here and this is my IP address. This is something that the Hermes standard, while it didn't need to be part of the standard, it can be a side extra, because at the moment we have to type in IP addresses and port numbers and host names, and so we don't really want users to do that. So it really does improve the user experience, as I've already demonstrated, when you can populate a drop-down box and say connect to that device there with its a nice name rather than an IP address. So it has SSDP discovery given out the box, which means anytime you install the MultiPlug, you can have that discovery feature. MultiPlug can be installed on Windows or Linux, and you can use that as a way of then upgrading your existing solution, maybe your desktop application type solution. Whether it's a control solution, it might be a controlling industrial equipment, but you can use a MultiPlug just to do that initial upgrade. I'm going to speak about how you can change and swap and change extensions, and you can get local remote changes in functionality. So let's go over quickly the extensions. So all the extensions adhere to an API, and that API has permissions. So that's quite standard stuff. You don't want extensions to do things you don't want them to do. So you've got the Hermes extension, which obviously gives you all the main Hermes functionality, the user interface, the APIs, the messages, but the messages themselves get pumped into the network sockets extension that handles the actual connections to other machines upline and download line. We've got the GPIO extension, and this handles local I/O of the adapter. But in this scenario, you could easily replace this extension for a connection to either a local machine, i.e. the manufacturing equipment you're talking to, and creating a software interface between here and your local machine, your local device. Or you can just swap in another type of physical I/O extension. So for example, when we were doing the development, we were actually not talking to this GPIO extension. We were talking to an extension that allowed us to have an Ethernet based connection to a I/O device that was actually remote from the development device. So you can see how this concept becomes a big building blocks of a solution. Serial port, we use that for connecting to, for example, conveyors to change the width, but then again you can use it for how you see fit. As if you just want some of the Hermes data every time it appears to go down the serial port, then you can quite easily do that. Then we got a recipe file extension, and this really handles the saving and loading of all the settings of the entire MultiPlug platform. All extensions can do that, but this has got permissions to do that. So essentially this is just saving to a file and loading to file, which means you can use one extension to control another extension via a recipe, but obviously there's breaking down the recipe, there's the actual individual settings. So that's the kind of block diagram view of how MultiPlug works and the solution of the adapter. Let's have a look at it in actual working and how that relates. So in the configuration area, you'll see extensions down the side here, and those are all the extensions that we were talking about earlier. And then you've got apps, which the extensions can say, I've got an app, here's the actual main Hermes user interface. Each extension, again, it's all optional, can provide themselves with a settings area. So here we've got the Hermes setting. Hermes extension can control multiple lanes. Here we just got one lane, and let's just run a board through to show you the workings of the actual extension. So these are the simulators that are available on the Hermes website. So if I send the service description down from the up line, you can now say it's waiting for board, and I can do the same for the down line. And now it says not ready, but then I can say machine ready, waiting for board. So this middle section reflects the SMEMA states and the actual equipment you're attaching it to. So we can see that it is ready, which means SMEMA is saying it's ready, and there's nothing in the machine, so it's saying no board. So if we send the board down the machine, we can see it's been ready, so it's already transporting, and the conveyor will say no, I'm no longer ready anymore. So if you look at this area here, it will turn not ready, which means transporting is stopped on the conveyor, and the Hermes would have either stopped beforehand or would have continued until waiting for the message to say stop transport. So now we have a board in the machine. It will do its stuff, and then when it gets to the end, SMEMA will go available again. So then we can say good board available, ready to receive, and then the down line will say start transport. It's now transporting to the machine. If it got to the machine before or after, it might go stop transport, or the conveyor might go I'm no longer ready because the board is transferred through, so that it doesn't really matter which sequence that occurs in, but it will obviously continue in the normal manner that SMEMA would work. So now that board is transferred down the machine, down the line, and if we go to the bottom, we can see that the board's now in the history of the downline. You can set how many boards you keep in the history. It's available there for a query board info, so upline machines can interrogate this via the Hermes standard. There is also a REST API, so you can query it via other means and by other systems, which means actually this kind of becomes a database. So you could easily look up old boards that have moved down the machine from other areas, not just the Hermes standard, but higher level systems potentially. So quick overview. So service descriptions, you get all the service descriptions of the boards. This station, so that's all the setup, that's all the measurement setups of the actual the current equipment you're connecting to. Scan station is a situation where the equipment you're connecting to is saying there's a board available, but there is no Hermes data. So this is a queue of data, of board IDs that essentially get matched up. So as soon as the equipment says there's a board, the board data gets taken from this queue, and then you can see the current SMEMA states. So I can toggle that as so. So let's change the width of the, so let's make SMEMA ready. Let's change the width of the board and show you a either manual or automatic machine width change. So if I do board available right now, you see there's a station parameter mismatch. So this station believes that it's up, that it is 60 width, but the next board is 100. Now what that has done is sent down the serial port the new width. And if we look at the documentation of this current conveyor, this is exactly the sort of format that they require. So that conveyor would have now seen that string, and then you can do one or two things, and you can set it up to do automatic or manual or both. You can either press continue right now and then it will just continue, or in that scenario the message has been sent via the serial port. The conveyor would have gone not ready, so now it's not ready. It would have changed the width, it would have then completed, and then it would have gone ready, and now the transport occurs. There's multiple ways of doing that. There is a feedback loop you can create, so a conveyor can reply back to say I finished, or it could just use the SMEMA signals to go off and on, or if the SMEMA signals don't change for any reason, maybe it's used board forecast messages to automatically adjust prior to being sent it, then you can set things like timeouts or rechecks. So we've got transporting now. Finished transport. SMEMA goes to low. Board does its thing. Good board ready. Machine downline ready. Start transport. Stop transport. SMEMA goes low. Machine board is down the machine. As I said before, if a board was placed in the on the conveyor or in the machine when there was no Hermes data, so if I then flag the SMEMA signals to go good board and the downline was ready, you will see a screen to manually populate
board information, and there is functionality that you can use a board lookup, board query info, to populate this information, or if you've got data in the scan station queue, it will take it from that, like so. So you can enter that, but we've flagged that to be not available anymore. So that's the principle of it. As I say, it can run multiple lanes, and as I said before, the actual I/O can be remote. So this software could run on a potential line server and it can communicate via other means of I/O rather than using adapter, but the adapter obviously is all the solution in one box. So let's just quickly go over some of the settings. So we have the lane, we have a status of the lane, setup, so we can have a pass-through scenario where we're actually just using this software as basically a man in the middle to collect the data of the Hermes standard and pass it through to the next connection. We've got measurements of the actual equipment, so as you see now it's set to 100 because we've done that change. Got lane direction, so left to right, right to left. We've got all the Hermes set up of what this machine is called. We've got the check alive event, which is just to maintain the Hermes connection. We've got a delay of saying machine stop, so maybe with all these situations you sometimes need delays between moving boards from one conveyor to the next. You can't really have a scenario where a sensor is placed incorrectly and the belt suddenly jerks to a stop and it's between belts. I've seen that before, where you presume that the sensors are linear and you actually find that the stop one is before the start one and the start one is before the stop one, which is so you have to get around that by not moving the sensors but actually fixing it by software, which is always a thing the hardware community like to do, which fix things by software rather than hardware. Board query, so that gives the ability to retrieve board query information I was talking about earlier. Mismatch, so this is the classic width is changed scenario. So you can say when the values change, create an event. You can say whether it's operator approval or automatic changeover. There's the event that gets fired off that the serial port then subscribes to. There's machine ready events, which normal scenario is just a SMEMA, but you can create virtual ones that attach the serial port, so the serial port can reply back and say I'm good, and that creates a machine ready scenario. So they all have to be true to proceed, and this just resets the ones that aren't latched. And again, there's the delay I was talking about earlier on, about if the SMEMA doesn't toggle off and on within a certain amount of time, then you can take it for certain that the machine is ready. Formats, as I said before, with this particular conveyor, there's a certain amount of zeros and things like that requires, which is the value of the measurement. I'll talk to you in a minute how to actually do this this before and after values. If the SMEMA equipment uses the failed signal, here's the machine ready subscriptions. So this is attached to the actual physical I/O, the SMEMA physical, but you can actually create some virtual ones where other systems can say whether it's good or bad, and some of them latch and some of them don't latch. So the ones that don't latch will, when reset, will reset to false. And these are the other events to the actual physical I/O. Downstream, again, check a live event. So this is the board query information. So at the moment we store 50 boards. I think that's in the standard, I can't remember, but you can set as many as you would like. So essentially you could create a mini database out of the boards that have passed through, or you can potentially load up the system with new boards and then use this software to query, allow this to be a kind of start point, and the downline machines query it. Send forecast. So there's an optional requirement to send the board information prior to it leaving the device, so upline can get ready for it. And that was, I was talking about conveyors might be ready or equipment might be ready. So all this information gets sent currently, but you can actually toggle off which values need to decide when a board forecast gets sent. Of course, we don't really have information of how long it's going to take for the machine to process the board, so we have to create a static value here. So this is 3 seconds, so it's a workaround. We'll have to think about whether we can get that information in the future. New functionality is command control, which was put on to 1.4. Again, it is optional, but that tells downline machines where to move equipment onto, whether it needs to be diverted or move into other lines, for example. I believe also that allows you to stop an entire line. So obviously we would stop the line and not let any boards proceed onwards. Flip board, so if your equipment is flipping a board, then this is a value to change. So if it's a flipper, you want to change to flipped or invert the flip. Okay, I might have misread that command actually. That command might be root. That's what I was talking about, I think. So you can set different routes, which is a very flexible value. It's not really defined at the moment, an action. So you can say to the next machine to not process the board, which potentially might be an opportunity to put that on the front user interface so the operator can decide that. But again, that will be an option. Board starvation, well, that's, as I was talking about earlier, that's when the SMEMA equipment says there's a board available, but there's no Hermes data associated with it. So what to do? Operator manual entry, as I've shown, scan station query, or just auto-generate some board information. And that's the XML messages from the network socket, and those are all the events to the actual I/O. So that's how that's all set up, and the scan station is a similar approach where you just subscribe to something that provides you with that data. That could be just simply the barcode number, or you can pass the barcode number to a database lookup, and then that database lookup then flows down all the values you require, because you're going to require all these values, so you can't just get that from a barcode number, but you could just auto-generate if you require. Let's take a look at serial port, because we were talking about how to do the the different string values. So essentially what we got here is these are the ports, so serial ports. So there's 4 USB, well there's the serial port that's attached to the actual adapter, but there's also 4 USB ports, which means this is a very flexible device. I mean, it's far more flexible than other devices I've seen on the market. And it's a computer at the end of the day, so you can attach a USB to serial port adapter to the USB port, but this gives you the default serial port. And so we got a write values, and then we've got the subscription, so that's a mismatch event described to that, and then we're writing a prefix and append. So SDW is the same as what we saw of these Nutek conveyors. SDW, and then the value, and then 01, 015, and that can be changed if required. Network sockets. Okay, we got endpoints which goes down to the down line, and we've got a client that goes to the up line. So simple setup here really. You've got the IP address, port number, blah 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 blah, and you've got the event and description of that. Simple stuff. And then you've got the GPIO, which is the actual connection to the SMEMA. Again, that can be dropped out, and you can use so you could replace that with a really simple connection to your local device, your equipment. That would be a 5-minute job to do that. Or you can use other devices. As I say, we used an Ethernet based IO device, and that's pretty much brings you back to the beginning. So different lanes will be there if you have multiple lanes. Well, that's it really. Certain devices would allow more than one barcode, more than one board in at a time, so you can have multiple boards, and then you can set somewhere somewhere in the software. You can set whether it's a first in first out or it's first in last out. So if you've got a flipper, obviously a flipper would take in lots of boards, and then not a flipper but a buffer, sorry, a buffer would take in multiple boards and then put them out as soon as the downline is cleared. In that scenario, I don't believe we can do board forecast, because we don't really know at what point the buffer is going to allow the boards out the machine. I don't think we know the order, so therefore it's hard to forecast what board's going to go in next until the buffer's up to its maximum. But I might be wrong with that one. But it's all flexible, and this is all upgradable software. This is all working with multiple customers with multiple different types of equipment. So things like inspection stations, for example, maybe you want failed boards from a SPI to go into an inspection scenario. There will be queues for that very shortly. But this is what you could say basic functionality from now. Anything more, just give us contact and we'll tell you where it is on the roadmap, because as I said, this is mirroring what hardware is already out there, so we kind of know what the hardware what it does. So therefore, it's very easy for us to justify improvements, because it's going to be beneficial for other customers with the similar equipment. So don't be afraid to contact us, because we're probably likely already working on it. So I hope that helps. Again, I'm really pleased with that Productronica launch. I'm sure at the end of this there'll be a page where it will show you where to buy the adapters from. It's been a great year so far. I'm really impressed with the sales of it, and it's just lovely when I can tell customers are Googling the problem and they're coming across the product and it's doing the job and solving the problem that they have, which is to roll out Hermes. CFX development is in the pipeline, and again, lots of customers are requesting CFX development. So once again, this is a very future-proofed and upgradable device. You're not buying in something that has a high level of firmware or a high level of lack of upgradable options. I mean, this is the next generation now of smart factory technologies, and so it needs to have that level of upgrade and level of, software will save the day essentially. So please subscribe to the newsletter, or any contact information is available on the website, but again, that will be all the end. So I hope that gives you a good overview of the SMEMA Hermes adapter.